Hey, Mrs. Pierce here. So I got a couple emails from some of you saying that you weren't sure about tonight's homework. So my goal for this is to help you guys to be able to choose input values wisely, especially for the first chapter. We're going to be graphing a lot of things, some square roots, some cube roots, some absolute values, some parabolas. And so when you get to decide which values to plug in for x, it will make a big difference, especially since you can't use a calculator. So hopefully this will help. Okay, so first what I would want you to know is what a perfect square is and what a perfect cube is. So when we square a number, for example, if I took 1 and I squared it, I would get 1. 2 squared, 4. 3 squared, 9. Sorry, this marker's not working too hot. 4 squared is 16. So the numbers on the right then are perfect squares. So these guys over here, those are called perfect squares. Because if I take the square root of them, I'm going to get an integer back. Okay? So these are the numbers over here that you're going to be needing to think about when we're talking about square roots. On the other hand, as far as perfect cubes, think about when you cube a number. It's when you take a number times itself 3 times. So 1 cubed, or 1 to the third power, is 1. 2 to the third power is 8. Negative 2, actually. Now I'm going to put parentheses around this because it's the whole thing that I'm going to cube. Negative 2 to the third power is negative 8, not positive 8. 3 to the third power, 3 times 3 is 9, 9 times 3 is 27, and guess what? Negative 3 to the third power is negative 27. And the list goes on. So perfect cubes and perfect squares, those are numbers that I want you to think about. Whenever I have to do this, actually, sometimes I just make a list on my paper of the perfect squares so I can see them visually and know what my goal is, and also perfect cubes so that I know what my goal is there. All right, so maybe you want to write this down, maybe not. You can always rewind it. Remember, that's the cool thing about a video. So let's go on to the next slide. So as an example, here's 3 examples similar to what I want you to do today. Let's start with the bottom. And so in the bottom one, if I had asked you to make a table of values to graph this function right here, you can put any numbers you want. Unless I tell you what numbers to do, you can put anything you want. And if you can put anything you want to choose wisely so that you're not trying to graph crazy decimals or fractions. That just gets messy. So if you look at my denominator here, when I'm multiplying by a fraction, if I want to cancel out that denominator, in this case, I'm going to choose multiples of 6, or 0. 0 works as well. So if I wanted to choose numbers for x, for that bottom function there, I personally would go with negative 6, 0, 6, maybe 12, 18, negative 18. Depends on how big my graph paper is. I don't have enough room right now, but you get the idea. So when I multiply by a multiple of 6, my denominator is going to cancel. I'm going to end up with an integer. So negative 6 times 1/6 is negative 1. Negative 1 plus 3 is 2. 0 times 1/6, well, that's 0. Plus 3 is 3. 0 is always nice. And then 6 times 1/6 is 1. 1 plus 3 is 4. Okay, so that's an idea if you have a fraction and you're multiplying it by x. Think about the denominator. Any multiple of the denominator is going to cancel that out. Those would be wise choices for your inputs. All right, let's look at the top now. In the top, this is a square root. That is a radical sign, and there is nothing in between that little check marky thing, so it's a square root. And now if I want y to be an integer so that I can graph it pretty, I need to think of what values could I put in for x. So in the previous slide, we were talking about perfect squares. I'm just going to go over here on the left and write down some of my perfect squares. I had 1, 4, 9, my commas aren't showing up too well here, 16, 25, and the list goes on. So those are some of my perfect squares. So let's think about this. If I wanted to end up with 1 underneath this radical sign, what would x be? Well, it would be -2. So if x was -2, then what's under the radical sign would be 1, and the square root of 1 is 1. All right, so if I wanted what's underneath the radical sign to be 4, I need to think, what could I add to 3 to get 4? Well, that would be 1, and 1 plus 3 is 4. The square root of 4 is 2. Same with 16. What would I add to 3 to get 16? Well, that would be 13. I skipped 9, that's okay. And then 13 plus 3 is 16. The square root of 16 is 4. And I could go and do the same thing with the others. So again, the values I was choosing for x were just nice, wise choices, so that I'm looking ahead, I'm going to get integers when I take the square root. All right, so the middle one, this is a cubed root. This little, when there's a 3 in front of the index, it's a cubed root. It's kind of like square root, but this I'm thinking, what can be multiplied by itself 3 times, and then you take the cube root of it. So it's the opposite of cubing something is the cube root. And in the previous slide, our perfect cubes were 1, -2, oops, sorry, not -2. That would be -8. Let me erase that. The cubed root of -8 is 2, or -2. So -8. And what I do in my head is I go through the numbers. So how about 3? 3 times 3 times 3 is 27. So 27 is 1. I could have +8. I could have -27. And the list goes on. So now if I'm going to make a list of values, so again, I'm going to look underneath the radical sign. I want what's under there to be 1. And if I want what's under there to be 1, x is going to be -2. And so when I add -2 to 3, I get 1. The cube root of 1 is 1. Okay, so what if I want what's underneath the radical sign to be -8? Well, what plus 3 is -8? That would be -11. So if I chose -11 for x, I would end up with -8, and the cube root of -8 is -2. Last, if I chose 27, what number plus 3 is 27? That would be 24. So 24 plus 3 is 27. The cube root of 27, remember 27 is what I'm choosing for x, cube root of that would be 3. Okay? All right, so hopefully that helps. Again, it's just a matter of helping you guys to manipulate numbers to make your life easier. We'll talk about it more tomorrow.